Hello, my friend, and welcome to the Sleepy Scholar. Tonight, we are going to talk about the cosmos, not as a subject to master, not as a test to pass, but as something closer to a very old, very patient ocean, one made of light instead of water, stretching so far in every direction that its edges are not really edges at all, just places where our eyes run out of reach before the universe does. The cosmos is not something you learn once and finish. It is something that simply continues, the way breathing continues, the way a heartbeat continues, whether or not anyone is paying attention to it. You may have had a long day. Your mind might still be turning over small, unfinished things, a conversation, a task, a worry that doesn't have a shape yet, just a weight. That's all right. You don't need to solve anything tonight. Some people count sheep. You've chosen something a little larger and a little quieter. A slow walk through galaxies and starlight, not because you need to remember any of it, but because it's a gentle place for a tired mind to rest its attention. There is nowhere else you need to be tonight. Nothing here is urgent. We're simply going to wander slowly through some of the oldest and gentlest facts we know about stars, about planets, about the long dark spaces between things, about the quiet machinery of a universe that has been unfolding for a very long time and is in absolutely no hurry. If these gentle journeys ever help you drift off, you're welcome to like or subscribe quietly whenever it feels right. It simply helps other sleepy souls find their way here too. But that's not why we're here tonight. We're here so you can rest. So let's begin the way we always do, not with facts yet, but with your body. Let your shoulders soften just slightly wherever they are right now. You don't need to move them. Just notice them and let them fall a little heavier into whatever is holding them up, a pillow, a mattress, a chair. Let your jaw loosen. Most of us carry a little tension there without noticing, a small clench that's been sitting quietly all day. You can let that go now. There's nothing to hold on to with your jaw tonight. Let your breathing slow, not by forcing it, but just by giving it permission. In and a little longer out. There's no rhythm you need to get right. Your body already knows how to do this part. It has been doing it since before you could think in words. You don't need to remember anything I say tonight. You don't need to follow every sentence, or stay awake for the ending, or hold onto a single fact. Nothing here is a test. If your mind wanders off halfway through a thought, that's not a failure. That's exactly how this is supposed to work. Thoughts can drift in through one ear and quietly dissolve before they reach the other side. And that's all right too. Even your mind tonight doesn't need to do its usual job of predicting and planning and sorting through the day. Most of what your mind does all day long is quietly guess what's coming next and check those guesses against what actually happens. A tireless, patient prediction machine running quietly in the background of everything you do. Tonight, it can simply listen instead, the way you might listen to rain against a window. Not to understand the rain, just to let the sound be there, without needing to predict a single drop of it. So let your mind drift, and let your body settle as we begin to wander gently through the cosmos. The iron in your blood was forged inside a star that died before the sun was ever born. Long before Earth existed, a star somewhere in the galaxy lived out its long, slow life, burning hydrogen into helium, helium into heavier things, layer after layer, the way a candle slowly reshapes its own wax. When that star finally died, it didn't vanish quietly. It scattered itself, flinging carbon, oxygen, calcium, and iron out into the dark, like seeds thrown from a very old hand. Those elements drifted for a long time, cooling, mixing with gas and dust, waiting. Eventually, some of that scattered material gathered itself into a new cloud, and that cloud became part of what would form the sun, the earth, and everything standing on it. The calcium in your bones, the iron carrying oxygen through your blood right now, the oxygen itself. All of it came from stars that lived and died long before there was a you to carry it. Tonight, some small part of that ancient fire is resting quietly inside you, doing nothing more dramatic than helping you breathe. There is something else worth resting on for a moment. A single year of light traveling, what we call a light year, is almost 6 trillion miles. It's not really a measure of time at all, though it wears time's name. It's a way of describing distance, using the one thing in the universe that moves fast enough to make the distances make sense. If you tried to picture 6 trillion miles as a stack of ordinary miles, you'd run out of imagination long before you ran out of miles. So instead, astronomers borrowed light speed as a kind of ruler. The nearest star beyond our sun is a little over 4 light years away, meaning the light leaving it tonight left 4 years ago and has been traveling silently ever since, arriving in your sky at almost the exact moment you happen to look up. Some of the stars you might glance at tonight are so far away that their light left before you were born. In a very real sense, when you look at the night sky, you're not seeing the universe as it is right now. You're seeing a very old letter, still arriving. But that is only one small part of the story. The universe itself had a beginning, though it might be gentler to say it had a starting stillness rather than an explosion, space itself stretching outward from something almost unimaginably small and dense. Nearly 14 billion years ago, it wasn't like a bomb going off in a room, throwing pieces outward into empty space. There was no outside yet for anything to fly into. Instead, space itself began to expand, carrying galaxies apart from each other the way raisins in a rising loaf of bread drift apart. because they're moving through the dough, but because the dough itself is growing between them. This means every point in the universe can, in a strange and comforting way, think of itself as roughly the center, because everything is moving away from everything else, evenly, in every direction. There was no favored spot where it all began that you could travel back to and stand in. The beginning wasn't a place. It was a moment, still gently unfolding. You are living inside that unfolding right now, at this very quiet hour. There's a very faint warmth still humming in every direction of the sky, left over from the universe's earliest days. It's called the cosmic microwave background, though you don't need to hold on to that name. What matters is the idea. About 380,000 years after the universe began expanding, it had cooled enough for light to finally travel freely for the first time, instead of being trapped and scattered by hot, dense particles. That first light has been stretching and cooling ever since, and it now reaches us not as visible light, but as a faint microwave hush, arriving evenly from every direction, like a very old, very soft static. If you had a receiver tuned to just the right frequency, a small portion of the static on an old television screen would actually be this ancient light older than every star, every galaxy, every planet you could name. It means the oldest light in the universe is not hiding somewhere far away. It's arriving everywhere, all the time, brushing softly against everything, including you. There's something else worth resting on for a moment. The very first stars in the universe were unlike any star burning tonight. Before those first stars, the universe was almost entirely hydrogen and helium. No carbon, no oxygen, no iron. None of the heavier elements that would later become planets, oceans, or people. So the first stars formed from nearly pure gas, and without heavier elements to help them cool and settle gently, they grew enormous, some far larger and hotter than any star alive today. They burned fast and bright and didn't last long in cosmic terms, but in dying, they did something the universe had never done before. They created and scattered the first heavier elements, seeding the space around them with the raw material for every rocky planet, every ocean, every living thing that would eventually come after. In a sense, you owe your existence to stars so ancient and so different from our sun that nothing quite like them exists anymore. They lived briefly, burned violently, and left behind the ingredients for something quieter and longer lasting. There is one more thing worth noticing before we drift onward. Stars are not born alone in empty space. They're born inside enormous, cold clouds of gas and dust, places astronomers call nebulae, though they might just as easily be called sky gardens. Inside these clouds, gravity slowly pulls threads of gas together, clumping and thickening over thousands of years, until a dense knot at the center becomes hot enough to ignite. One cloud can give birth to hundreds or even thousands of stars at once, siblings born from the same drifting material, eventually scattering apart to live out separate lives across the galaxy. Some of these nebulae are lit from within by the very stars they're creating, glowing faintly pink or blue or green, depending on which gases are present. Hydrogen glowing rose-colored, oxygen glowing a pale, ghostly teal. The sun, too, was born this way, inside a cloud like this, alongside sibling stars that have long since drifted off into other parts of the galaxy, scattered far enough now that we may never be able to point to any of them and say, "That one used to be a neighbor." Every star that shines steadily tonight is also, very slowly, dying. A star like our sun spends most of its life in a long, stable middle age, quietly fusing hydrogen into helium at its core, holding itself up against its own gravity with the outward pressure of its own light and heat. But that fuel isn't endless. Billions of years from now, the sun will begin to run low on hydrogen at its center, and it will start to swell, not violently, but gradually, like dough left to rise too long. It will become what's called a red giant, growing so large that it may swallow the closer planets entirely, eventually having puffed away its outer layers into space as a soft, glowing shell. It will leave behind a small, dense ember called a white dwarf, no longer producing new light through fusion, but still glowing faintly from stored heat, cooling for trillions of years, far longer than the universe has even existed so far. None of this is happening on any timescale that touches you directly. It is simply the quiet shape of a star's whole life, unfolding the way a long, slow exhale unfolds, rising, expanding, and finally settling into stillness. But that is only one way for a star's story to end. Stars much more massive than the sun end their lives very differently, and far more suddenly. When a giant star finally runs out of fuel, it can no longer hold itself up against its own gravity, and its core collapses inward in less than a second, while its outer layers rebound outward in a colossal explosion called a supernova, briefly outshining every other star in its entire galaxy combined. What's left behind, if the star was massive enough, is something almost impossible to picture. A neutron star, a leftover core so dense that a teaspoon of its material would weigh more than a mountain here on Earth. Some of these neutron stars spin unbelievably fast, sweeping beams of radiation around like a lighthouse, flickering into view from Earth as a steady, ticking pulse, which is why we call them pulsars. Somewhere in the sky tonight, one of these tiny, impossibly dense stars may be spinning hundreds of times every second, having done so faithfully for millions of years, entirely unnoticed by anyone standing quietly under the stars. There is something else worth resting on for a moment. If a dying star is massive enough, its collapse doesn't stop at a neutron star at all. It keeps collapsing past any point where matter can hold itself up until it forms what we call a black hole. A black hole isn't a hole in the usual sense, and it isn't really black out of emptiness. It's a place where gravity has become so strong that nothing, not even light, can travel fast enough to escape it once it crosses a certain boundary, called the event horizon. Past that boundary, our usual ideas about space and time stop behaving the way they do everywhere else. Strangely, near a black hole, time itself slows down from the perspective of someone watching from a safe distance. A clock lowered carefully toward the edge would appear to tick slower and slower the closer it got, without ever quite seeming to reach the boundary at all, at least not from the outside. It's a strange comfort, in its own way, a reminder that even time, which feels so fixed and unshakable in your daily life, is really just another soft, bendable thread in a much larger fabric. Our entire galaxy is turning slowly, and you are turning with it. The Milky Way is a vast, flattened spiral of stars, gas, and dust, and our sun sits out in one of its quieter arms, roughly 2/3 of the way from the crowded center to the galaxy's faint outer edge. From here, we can't see the galaxy's shape directly, the way you can't see the shape of a forest while standing inside it. But we can trace its faint, hazy band stretching across a truly dark night sky, made of the combined glow of hundreds of billions of stars too distant to see individually. The whole galaxy rotates, carrying our solar system along with it, completing one full turn roughly every 225 to 250 million years. A span of time so long that the last time our sun and earth were in this same position relative to the galaxy's center, there were no flowering plants yet, and the dinosaurs hadn't appeared. Every slow breath you take tonight is happening while you are quietly circling the center of the galaxy at a speed of hundreds of miles every second, without the faintest sense of motion at all. There is something else worth resting on for a moment. Galaxies spin in a way that shouldn't quite be possible, based only on the stars and gas we can actually see. If you measured the mass of all the visible stars in a galaxy like ours, and used that to predict how fast the outer stars should orbit the center, the numbers don't add up. The outer stars move far faster than they should, fast enough that, by the ordinary rules of gravity, the galaxy ought to be flying apart. Something else appears to be holding it together, an unseen kind of mass, invisible to every telescope we've built, that we simply call dark matter, because we can only notice its gravity, never its light. It seems to form a vast, invisible halo around galaxies, far larger than the visible disk of stars, quietly providing the extra gravitational glue needed to keep everything from flying apart. We still don't fully know what it's made of. It's a strange thing to sit with, the idea that most of the gravity holding your galactic home together comes from something we've never directly seen, only inferred from the way everything else moves around it. There is one more thing worth noticing before we drift onward. Our galaxy is not alone, and it is not standing still relative to its nearest large neighbor. The Andromeda galaxy, our closest major galactic neighbor, is currently drifting toward the Milky Way, pulled by mutual gravity at a slow and steady pace. In roughly 4 billion years, the two galaxies are expected to begin merging, not as a violent collision of stars crashing into each other, since the space between stars is so vast that direct impacts would be exceedingly rare, but as a long, graceful, gravitational dance that reshapes both galaxies into something new over hundreds of millions of years. By the time this begins, the sun will already be nearing the end of its own life, swelling toward its red giant phase. It's a strange, oddly comforting thought that two enormous cities of stars, drifting for billions of years through the dark, are slowly leaning toward each other, patient enough to wait for a future so distant that almost nothing alive today will be there to see it arrive. If you could zoom far enough out, the universe wouldn't look like a scattering of random dots. It would look almost like lace. Galaxies aren't spread evenly through space. Over the largest scales we can map, they gather along enormous filaments, long, thread-like structures of galaxies and gas, stretching across hundreds of millions of light years, connected at busy intersections called galaxy clusters, and separated by vast, nearly empty regions called cosmic voids, some large enough to swallow whole clusters of galaxies in their emptiness. Astronomers sometimes call this the cosmic web, and the name fits. From far enough away, it really does resemble a glowing, three-dimensional net, with our own galaxy sitting somewhere along one of its softly lit threads. You live inside one strand of an almost unimaginably large structure, one thread among many, each one made of galaxies, each galaxy made of stars, each star quietly living out its own slow, private story. There's something else worth resting on for a moment. Long before there were rocky planets or oceans, or anything resembling a sky to look up at, there was simply a swirling disk of gas and dust, spinning slowly around a newly forming sun. Out of that disk, tiny grains of dust began to stick together, first into pebbles, then into small rocky clumps, then over millions of years into larger and larger bodies, some growing massive enough for their own gravity to pull them into round shapes, becoming the planets we know today. The leftover material that didn't gather into planets stayed behind as asteroids, comets, and scattered debris, some of which still drifts through the solar system now. It's a strange thing to consider that the solid ground beneath your feet and every rock, mountain, and grain of sand on Earth began as fine dust, gently swirling and colliding in the dark, patiently building itself into a planet over an unimaginably long stretch of time. There is one more thing worth noticing before we drift onward. The sun looks utterly steady and reliable in our sky, and in most ways it is, but it is also, quietly, unimaginably violent, in a way we rarely think about. At its core, the sun fuses roughly 600 million tons of hydrogen into helium every single second, releasing the energy that eventually reaches Earth as warmth and light. After a journey that takes tens of thousands of years, just to travel from the sun's center to its surface, before finally crossing the 8 light minutes of empty space to reach you. The sun also constantly sheds a thin stream of charged particles called the solar wind, which flows outward through the entire solar system. When those particles reach Earth and collide with our planet's magnetic field, they can produce shimmering curtains of light near the poles, the aurora, dancing green and sometimes red and purple across the night sky, a visible trace of an invisible wind that never stops blowing. Every warm afternoon you've ever felt on your skin was the tail end of a journey that began deep inside a star, tens of thousands of years before it ever reached you. The moon overhead tonight was very likely born from a violent collision billions of years ago that Earth itself barely survived. Early in the solar system's history, a Mars-sized world is thought to have struck the young Earth at an angle, in an impact almost too large to picture calmly. The debris thrown into orbit from that collision, molten rock and dust blasted skyward, gradually came together, cooling and settling into a single sphere, our moon. It formed close to Earth at first, glowing faintly molten in a much darker sky, and has been drifting slowly outward ever since, moving away by about 1.5 inches each year, a pace so slow it will take hundreds of millions of years to become noticeable at all. If that ancient collision had happened only slightly differently, there might be no moon at all. And without its steady gravitational pull, Earth's tilt, its seasons, and its tides might look very different, or might not exist in a form we'd recognize. There is something else worth resting on for a moment. The gentle rise and fall of the ocean's tides, twice a day, comes from something as distant and quiet as the moon's soft pull on our planet. The moon's gravity tugs slightly harder on the side of Earth, facing it, than on the far side, stretching the planet's oceans ever so slightly into an oval shape as Earth rotates underneath. As each part of the coastline turns to face, then away from, then back toward the moon over the course of a day, it rises briefly into a high tide, then eases back into a low one. The sun, too, pulls on the oceans, though more gently, and when the sun and moon align, their combined pull creates especially high spring tides, while at other times their pulls partly cancel out into gentler neap tides. It's a quiet, patient kind of influence, an object hundreds of thousands of miles away, invisible in its effect, except for the steady breathing of the sea, in and out, twice a day, every day, for as long as there have been oceans to move. There is one more thing worth noticing before we drift onward. Earth doesn't spin on a perfectly fixed axis. It wobbles very slowly, the way a spinning top gently tilts as it slows. This slow wobble, called precession, takes about 26,000 years to complete one full circle, and it means the star we currently call the North Star, Polaris, hasn't always held that title and won't hold it forever. Thousands of years ago, a different star sat near the northern point in the sky, and thousands of years from now, yet another star will quietly take its place. Ancient civilizations who charted the stars so carefully, building elaborate calendars and myths around fixed points in the sky, were mapping a sky that has been almost imperceptibly shifting the entire time, so slowly that no single lifetime could ever notice it happening. The sky you look up at tonight is, in this quiet way, not quite the same sky your ancestors looked up at, and not quite the same sky your descendants, thousands of years from now, will see. Long before telescopes existed, people were already drawing the sky by hand, tracing careful lines between stars to make sense of the dark. Old celestial atlases, the kind bound in leather with hand-painted constellations stretched across engraved copper plates, show the night sky not as scattered points of light, but as a menagerie. Bears, hunters, swans, serpents, and rivers, drawn directly over the stars themselves, as though the sky had been embroidered with mythology. Some of these figures, like the great bear or the hunter with his belt of 3 stars, have been recognized in roughly the same shapes for thousands of years, passed down from one civilization's skywatchers to the next. These old atlases weren't just decoration. They were working tools used by sailors, farmers, and astronomers to track the seasons, predict eclipses, and find their way across open water long before any other navigation existed. A single engraved page, careful and ornate, might have guided a ship safely across an ocean with nothing else to go on but starlight and geometry. There's something quietly moving about it. The idea that generations of careful hands, working by candlelight, sat and traced the exact same stars you might glance at tonight, giving them names and shapes so that no one, ever again, would have to feel entirely lost beneath them. There is something else worth resting on for a moment. For most of human history, the stars weren't just beautiful, they were essential, functioning like a slow, silent clock and compass combined. Sailors far from land, with no other landmarks, learned to measure the angle of certain stars above the horizon to figure out how far north or south they had traveled. Certain bright, reliable stars became known as guide stars, trusted the way you might trust an old, familiar landmark near home. Entire trade routes and migrations across oceans and deserts alike depended on this quiet, patient reading of the sky. It meant that on a moonless night, in the middle of an empty ocean with no other reference at all, a sailor could still know roughly where they were, simply by looking up and recognizing a pattern they had learned as a child. In a way, the stars were humanity's oldest reliable map, one that never needed updating, since it had been drawn the same way, night after night, for as long as anyone could remember. There is one more thing worth noticing before we drift onward. On certain very dark nights, especially just after sunset or just before sunrise, a faint, soft cone of light can sometimes be seen rising from the horizon, not from any city or moon, but from countless tiny grains of dust drifting in the plane of the solar system itself. This gentle glow, called the zodiacal light, comes from sunlight reflecting off dust left behind by ancient comets and asteroids, scattered thinly along the same flat plane in which the planets orbit. It's faint enough that most people never notice it at all, especially with modern lighting nearby. But in truly dark places, it can appear as a soft, hazy pyramid of light leaning up from the horizon, easy to mistake for the first hint of dawn. It's a strange, quiet reminder that even the empty-looking space between planets isn't quite empty. It's faintly, gently dusty, catching sunlight in a way visible only to those patient enough to watch a truly dark sky. Mars was not always the cold, dry, rust-colored world we picture today. It may once have had rivers, lakes, and perhaps even a shallow ocean. Looking at Mars's surface now, spacecraft have found dry riverbeds winding across the landscape. Smooth stones rounded the way only flowing water can round them, and mineral deposits that typically only form when rock sits in water for long stretches of time. Billions of years ago, Mars likely had a thicker atmosphere, capable of holding onto warmth and liquid water on its surface. Over time, Mars lost most of its atmosphere, possibly stripped away gradually by the solar wind, Since Mars's core cooled early and lost the magnetic field that might have shielded it, the way Earth's magnetic field shields us. Without that protection, the atmosphere slowly leaked away into space, and the water that once flowed across the surface either froze, sank underground, or drifted off along with the air. It's a quiet, sobering kind of fact. A whole planet that may once have looked, in a modest way, a little like a young, rustier Earth, slowly losing its atmosphere and its water over an unimaginably long, undramatic stretch of time. There is something else worth resting on for a moment. Venus, similar in size to Earth, and sometimes called our sister planet, ended up as one of the most hostile places in the solar system, with surface temperatures hot enough to melt lead. Venus's thick atmosphere, made mostly of carbon dioxide, traps heat so effectively that its surface stays scorching hot day and night, all year, everywhere on the planet, regardless of season. Thick clouds of sulfuric acid drift above a surface pressure, so crushing it would feel, to a person standing there, roughly like standing nearly a mile underwater on Earth. Some scientists think Venus may once have had oceans of its own, long ago, before a runaway greenhouse effect took hold, a slow spiral where rising heat evaporated surface water, and that water vapor trapped even more heat, and so on, until any oceans it once had were boiled away entirely. It's a strange, uneasy kind of mirror. A planet so similar to Earth in size and origin, yet shaped by a slightly different set of circumstances into somewhere almost unimaginably different. A quiet reminder of how delicately balanced a livable world can be. There is one more thing worth noticing before we drift onward. Two small, icy moons, one circling Jupiter, the other circling Saturn, may be hiding vast oceans of liquid water beneath their frozen surfaces, kept warm not by sunlight, but by the gentle, relentless flexing of gravity. Europa, one of Jupiter's moons, has a smooth, icy shell etched with long cracks, and beneath that shell, scientists believe there may be a salty ocean containing more liquid water than all of Earth's oceans combined. Enceladus, a small moon of Saturn, has been seen venting tall plumes of water vapor and ice out into space from cracks near its south pole, offering a rare direct sample of what lies beneath its surface. Both moons are warmed, at least in part, by tidal flexing, the gentle, repeated squeezing and stretching caused by the gravity of the larger planets they orbit, generating just enough internal heat to keep liquid water from freezing solid, even so far from the sun's warmth, somewhere out past the orbit of Mars, sealed beneath miles of ice, in complete darkness. There may be quiet oceans that have never once seen sunlight, moving gently under the patient, repeated pull of a planet's gravity. Saturn's largest moon, Titan, has lakes, rivers, and rain, but none of it is made of water. Titan is cold enough, and its atmosphere thick enough with nitrogen that liquid methane and ethane, chemicals that are gases here on Earth, pool into lakes and seas across its surface, fed by rivers carved through icy terrain, and occasional rains falling gently from thick, orange-tinted clouds far above. It is, as far as we currently know, the only other place in the solar system with stable liquid currently flowing across its surface. A spacecraft that landed there years ago returned images of a strange, hazy, orange landscape. Smooth, rounded stones scattered across a dry riverbed, shaped by the same slow, patient erosion that shapes riverbeds on Earth, just carved by an entirely different kind of liquid. It's a gentle reminder that ocean and rain and river don't have to mean water everywhere in the universe, that entirely different kinds of weather, entirely different kinds of gentle, ordinary cycles might be quietly happening on a moon so cold and distant that its rivers run with liquid gas instead of liquid water. There is something else worth resting on for a moment. Between Mars and Jupiter lies a wide, scattered band of rocky rubble called the asteroid belt. Not a solid ring, as it's sometimes pictured, but a very sparse scattering of rocky bodies with enormous distances between them. These leftover fragments never gathered into a full planet, mostly because Jupiter's powerful gravity kept stirring the material, preventing it from settling calmly the way material elsewhere in the early solar system did. Instead, the region remains a loose collection of rocky and metallic bodies, ranging from tiny pebbles to Ceres, a dwarf planet large enough to be rounded by its own gravity. Despite how asteroid belts are often shown in movies, tightly packed with rocks constantly colliding, the real asteroid belt is mostly empty space. Spacecraft have flown through it several times without needing to dodge anything at all, because the average distance between asteroids is enormous. It's a quiet correction worth holding on to, that even in the places we imagine as chaotic and crowded, the universe tends to leave far more room than we expect. There is one more thing worth noticing before we drift onward. Far beyond the orbit of the outermost planets lies a vast, dim shell of icy debris called the Oort cloud, thought to surround the entire solar system like a faint, spherical halo. This distant cloud is so far away that light from the sun, which reaches Earth in about 8 minutes, might take the better part of a year to reach its outer edge. Occasionally, the gentle gravitational tug of a passing star, or the pull of the galaxy itself, nudges one of these icy bodies loose, sending it falling slowly inward toward the sun over thousands of years, eventually becoming visible from Earth as a comet. By the time a comet becomes visible in our sky, trailing its glowing tail of gas and dust, it may have been quietly falling toward us, alone in the dark, for longer than all of recorded human history combined. There's something oddly comforting in that thought. A small, icy traveler, drifting for millennia in near total darkness, finally catching enough sunlight to glow, if only for the brief weeks it passes near enough for anyone on Earth to notice. Some comets return again and again, on a schedule so long that a single human life usually only gets to see them once. Halley's Comet, perhaps the most famous of these visitors, swings past Earth roughly every 75 years, meaning most people alive today will see it, at most, a single time in their lives. It has been recorded faithfully by different civilizations for over 2,000 years. Ancient Chinese astronomers noted its appearances centuries before anyone understood what a comet actually was. And it appears, quietly documented, in old European manuscripts and tapestries long before telescopes existed. Each time it swings close to the sun, a little more of its icy surface boils away into space, meaning it is very slowly shrinking, appearance after appearance, century after century, though it will likely keep returning for tens of thousands of years yet. If you saw it once as a child, you likely won't see it again. A strange, quiet kind of appointment, kept once in a lifetime, exactly on schedule, by something that has been keeping the same appointment for thousands of years before you were ever born. There is something else worth resting on for a moment. A meteor shower isn't falling stars in any literal sense. It's Earth quietly passing through the leftover dust trail of a comet that swung through the same path long ago. As a comet travels closer to the sun, it sheds a thin trail of dust and small debris along its orbit, and that debris lingers in space for a very long time after the comet itself has moved on. When Earth's own orbit happens to cross through one of these lingering trails, tiny grains of dust, some no larger than a grain of sand, burn up brightly in our atmosphere, each one a brief, quiet streak of light we call a shooting star. Because Earth passes through the same debris trails at roughly the same time every year, meteor showers tend to return on predictable dates, night after night, year after year, faithfully, like a quiet appointment kept by the whole planet at once. Each tiny streak of light overhead is a small piece of a comet that may have passed by long before recorded history began, finally ending its long journey in a brief, silent flash above your head. There is one more thing worth noticing before we drift onward. Beyond Neptune lies another vast region of icy bodies called the Kuiper Belt, home to countless small, frozen worlds including the dwarf planet Pluto. Pluto, once considered the ninth planet, is now understood as one of many similar icy bodies scattered through this distant region, not demoted out of any unfairness, but reclassified as our understanding of the solar system's structure grew more precise. It's a small, cold world with faint pinkish patches of frozen nitrogen and methane, mountains of solid water ice, and even hints of a thin, hazy atmosphere. When a spacecraft finally flew past Pluto after a journey of almost a decade, it revealed a surprisingly varied landscape. Smooth, icy plains, towering mountains, and even signs of past geological activity on a world so distant that sunlight there is roughly 1,000 times fainter than on Earth, closer to a very bright twilight than a true daytime. It's a gentle thing to consider, an entire small world, quietly complex and geologically alive in its own slow way, sitting so far from the sun that daylight there barely resembles daylight at all. Not so long ago, we didn't know for certain whether any planets existed beyond our own solar system. Now we know of thousands. The first confirmed planet orbiting another sun-like star was discovered only in the 1990s. And since then, telescopes have found thousands more, some rocky and small like Earth, some enormous gas giants far larger than Jupiter, and some strange in ways we don't have good comparisons for at all planets that rain molten glass sideways in howling winds, or drift alone through space with no star to orbit. Astronomers often find these distant worlds not by seeing them directly, since a planet's light is easily lost in the glare of its star, but by watching a star's light dim slightly and rhythmically as a planet passes in front of it, blocking a tiny, measurable fraction of its glow over and over, like a very slow, very distant heartbeat. It's a strange thing to sit with, that's scattered across the galaxy, quietly circling other suns. There are almost certainly more planets than there are stars, most of them entirely unnamed, unnoticed, existing in complete silence, exactly the way Earth once did before anyone was here to call it anything at all. There is something else worth resting on for a moment. Around every star, there's a narrow, gentle band of distance where conditions might allow liquid water to exist on a planet's surface. Neither so close that oceans boil away, nor so far that they freeze solid. This modest band is sometimes called the habitable zone, though it's really more of a rough guideline than a guarantee. A planet could sit inside this zone and still be lifeless, shaped by the wrong atmosphere or the wrong history, and a planet just outside it might still hold liquid water beneath an icy shell, warmed instead by tidal flexing. the way Europa and Enceladus are. Earth sits comfortably within our own sun's habitable zone, close enough for warmth, far enough to avoid Venus's fate, tilted and rotating in a way that spreads that warmth gently around the whole globe instead of baking one side and freezing the other. It's a fragile, quiet kind of luck, in a way Earth landing, by the patient unfolding of gravity and chemistry, in exactly the narrow band of space and circumstance gentle enough to hold oceans, clouds, and eventually, quietly, you. There is one more thing worth noticing before we drift onward. Not every planet has a star to call home. Some drift alone through the galaxy, untethered, wandering through the dark, with no sun to orbit at all. These are called rogue planets, and they're thought to form the same way ordinary planets do, in a disk around a young star, before being flung out into interstellar space by the gravitational tug of a passing star or a larger sibling planet. Once ejected, they drift on their own, forever, cooling slowly in the near-absolute cold of deep space, lit by nothing but the faint, distant glow of stars they'll never get close enough to warm themselves by. Some estimates suggest there could be billions of these lonely wanderers scattered throughout our galaxy alone, each one drifting in near total darkness and silence, never circling anything, belonging to no solar system at all. There's something quietly moving about it, countless worlds, out there right now, tumbling gently through the dark with nowhere in particular to be, and in their own strange way, nowhere they need to be either. Every star carries a kind of fingerprint hidden inside its light. When starlight is gently split apart, the way a prism splits sunlight into a rainbow, it doesn't come out as a smooth, even band of color. It comes out marked with thin, dark lines, gaps where certain colors are missing. Each element, hydrogen, helium, calcium, sodium, absorbs a very particular set of colors, leaving its own unique pattern of missing lines behind, like a signature. By reading these patterns, astronomers can tell what a star is made of without ever touching it, sometimes without even being certain exactly how far away it is. The same method lets us know that the sun is mostly hydrogen and helium, that certain distant stars are unusually rich in iron, that some are almost entirely made of elements forged in earlier generations of stars that lived and died long before. It's a quiet kind of listening, starlight arriving after an impossibly long journey, still carrying, folded inside it, an honest little confession of exactly what it's made from. There is something else worth resting on for a moment. Nearly 100 years ago, an astronomer noticed something strange. Almost every distant galaxy she measured seemed to be moving away from us, and the farther away a galaxy was, the faster it seemed to be receding. This pattern showed up in the color of each galaxy's light, stretched slightly toward the red end of the spectrum, the same way a passing ambulance's siren stretches into a lower pitch as it moves away. Astronomers call this stretching redshift, and its steady pattern, faster recession at greater distance, was the first solid clue that the universe itself is expanding, carrying galaxies apart the way a rising loaf carries raisins apart within it. This single, careful observation quietly rewrote everything we thought we knew about the universe's size, age, and origin, tracing a line backward in time toward a single dense beginning, billions of years ago. It's a gentle thing to consider that such an enormous truth about the entire universe was first noticed simply by patiently measuring the color of very faint, very distant light. There is one more thing worth noticing before we drift onward. The universe isn't just expanding, it's expanding faster and faster, pushed along by something we don't fully understand, which scientists have simply named dark energy. For a long time, astronomers assumed the universe's expansion should be slowing down over time, since gravity constantly pulls everything back toward everything else. Instead, careful measurements of distant exploding stars revealed the opposite. The expansion is speeding up, as though some quiet, steady pressure is gently pushing space apart, faster with each passing billion years. We don't know what dark energy actually is. We only know its effect, patient and enormous, filling nearly 70% of everything that exists, quietly stretching the universe a little faster with each passing age. It's all right not to know. Some of the largest truths about the universe are held, for now, simply as careful observations, waiting patiently for a fuller explanation that hasn't arrived yet. There is something else worth resting on for a moment. Life on Earth has been found thriving in places once assumed to be far too harsh for anything to survive. Tiny microorganisms have been discovered living inside boiling volcanic vents on the ocean floor, in water far saltier than any sea, in solid ice deep within glaciers, and even in the highly acidic runoff of abandoned mines. Some can survive being frozen solid or dried out almost completely, or exposed briefly to the vacuum of space itself, only to quietly resume living again once conditions turn gentle once more. These hardy organisms, sometimes called extremophiles, have reshaped how scientists think about where life elsewhere might be able to exist, suggesting that life doesn't necessarily need a calm, Earth-like world at all, just a persistent pocket of liquid water and a little chemical energy to work with. It's a quietly hopeful thought that the boundary of where life can exist keeps turning out to be wider and gentler and more forgiving than anyone originally assumed. There is something else worth resting on for a moment. A newer space telescope folded carefully to fit inside a rocket, and then unfolded slowly in space like a great, patient origami. Now, lets us see farther back in time than ever before, because looking farther away always means looking further into the past. This telescope's very sensitive infrared eyes can catch the faint, stretched light of some of the very first galaxies to form, born only a few 100 million years after the universe began. It orbits far from Earth, shielded carefully from the sun's warmth, kept just a few degrees above absolute zero, so its instruments can detect the faintest possible traces of ancient light. Looking through, it is a little like opening a very old letter, one that has been traveling for over 13 billion years, arriving gently, finally, exactly now. There is something else worth resting on for a moment. Decades ago, 2 small spacecraft left Earth carrying a message meant for no one in particular, and possibly one day for someone very far away. Each spacecraft carries a golden record, engraved with instructions for playing it, containing greetings in dozens of languages, recordings of wind and rain, and a beating human heart, and music gathered from across cultures and centuries. They also carry a simple map, showing our sun's position relative to a set of well-known pulsars, a kind of return address written in the steady, patient language of the stars themselves. Both spacecraft have now left the sun's immediate influence entirely, drifting through interstellar space, carrying their quiet message outward at a slow, patient pace, expected to keep traveling long after Earth itself has changed beyond recognition. Somewhere out there right now, a small metal record is drifting through the dark, carrying a lullaby, or a heartbeat, or a greeting toward absolutely no one in particular, and possibly someday toward someone. There's something else worth resting on for a moment. Stars aren't all the same color, and their color quietly reveals how hot they are. A star's color depends almost entirely on its surface temperature, the same way a piece of heated metal glows first dull red, then orange, then a brighter yellow-white as it grows hotter. Cooler stars glow a soft, warm reddish-orange. Middling stars like our sun glow a gentle yellow-white, and the hottest stars burn with a fierce, pale blue, because our eyes are more sensitive to certain colors, and because starlight often has to pass through miles of atmosphere before reaching us. Most stars appear closer to white at a glance, and it can take a careful, patient look to notice their true, subtle tint. Next time you happen to glance upward on a clear night, you might notice, faintly, that not every star shines quite the same shade of white. Some lean warm, some lean cool, each one quietly announcing its own temperature across an unimaginable distance. There is one more thing worth noticing before we drift onward. Stars don't actually twinkle. The twinkling happens here, in our own atmosphere, not out there among the stars themselves. Starlight travels in a straight, steady line for nearly its entire journey, undisturbed for trillions of miles, only to pass through the last 100 miles of Earth's turbulent atmosphere, where shifting pockets of warm and cool air gently bend and jostle the light this way and that. That last second wobbling is what creates the soft, shimmering twinkle we see from the ground. Planets, being much closer, appear as tiny disks rather than single points of light, and this slightly larger size allows the same atmospheric jostling to mostly cancel out, which is why planets tend to shine with a calm, steady glow, while true stars flicker gently overhead. It's a small, quiet distinction, but a lovely one. The shimmer you notice isn't the star being unstable at all. It's simply the last, gentle breath of our own sky, brushing against light that traveled for years just to reach it. There is something else worth resting on for a moment. Astronomers measure how bright a star appears using a scale that runs backward from what you might expect, where smaller numbers mean brighter objects and larger numbers mean fainter ones. This system traces back over 2,000 years to early stargazers who simply sorted the visible stars into 6 rough groups of brightness by eye, calling the brightest stars first magnitude and the faintest visible ones sixth magnitude. Modern instruments have refined this ancient sorting into a precise mathematical scale, but the old backward logic remains, a quiet fossil of how people once patiently cataloged the sky using nothing but careful eyesight. Some objects are so bright they require negative numbers to describe them at all, while the faintest galaxies ever photographed sit at magnitudes so high they represent light almost too faint to imagine, gathered patiently over many long hours of exposure. It's a gentle little inheritance, worth noticing, a counting system invented by candlelight, still quietly used today to describe some of the most powerful telescopes ever built. There is one more thing worth noticing before we drift onward. In much of the world today, true darkness has become surprisingly rare, and with it, much of the night sky has quietly faded from view. City lights, scattered upward as well as outward, wash out all but the very brightest stars, and in many places, the soft, hazy band of the Milky Way, once visible to nearly everyone on Earth, has become something people have to travel to find. In truly dark places, far from artificial light, the sky can appear almost impossibly crowded with stars, far more than most people have ever seen at once. Some regions have begun protecting their darkness deliberately, dimming unnecessary lighting and shielding street lamps so their glow points downward instead of upward, quietly preserving a version of the night sky that used to belong to everyone. It's a gentle kind of loss worth noticing, and a gentle kind of hope too. that darkness itself, done carefully, can be protected, the same way any other quiet, valuable thing can be protected, simply by choosing to leave a little more of it alone. There is something else worth resting on for a moment. The space between stars looks completely empty, but it isn't quite. Scattered thinly across the vast distances between stars drifts a very faint mixture of gas and dust, called the interstellar medium, so sparse that a single cubic inch of it might contain only a handful of atoms. And yet, spread across the enormous scale of a galaxy, this thin, quiet material adds up to enough mass to eventually form entire new generations of stars. This faint material also gently dims and reddens the light of distant stars passing through it, the same way a hazy sky reddens a sunset here on Earth, meaning some of the starlight overhead has been softly filtered by clouds of dust older than the sun itself. Even the emptiest looking parts of the sky are never quite as empty as they seem, holding faint traces of material patiently waiting over millions of years to become something new. There is something else worth resting on for a moment. Saturn's rings, among the most beautiful sights in the entire solar system, are made of countless individual pieces of ice and rock, most no larger than a boulder or a snowball, orbiting together in a thin, flattened band. Despite stretching wide enough to fit several Earths side by side across their diameter, the rings themselves are remarkably thin, in places only a few dozen feet from top to bottom. A whisper-thin disk of icy debris circling a giant planet. Scientists still aren't entirely certain how the rings formed, whether from a shattered moon, a captured comet, or leftover material that never quite gathered into a moon at all. Up close, the rings aren't solid at all, but countless individual chunks, gently jostling and colliding, some clumping briefly together before drifting apart again. An enormous, patient, slow-motion dance that has likely been continuing for a very long time. There is one more thing worth noticing before we drift onward. The moon always shows Earth the same familiar face, night after night, because long ago it settled into a quiet gravitational rhythm with our planet. Early in its history, the moon rotated at a different rate than it orbited, but Earth's gravity gradually, patiently, slowed that rotation down through a gentle process called tidal locking, until the moon's spin and its orbit matched exactly. Now, the moon turns just once for every full trip it makes around Earth, meaning the same face has quietly watched over Earth for longer than anyone can remember, while its far side remained hidden from human eyes until spacecraft finally photographed it. It's a quiet, patient kind of settling, the same shape, in its own way, as a held breath slowly easing into a calm, steady rhythm, two bodies, tugging gently at each other for long enough that they finally, quietly, agree. On rare occasions, the moon passes directly between the Earth and the sun, and for a few brief minutes, day quietly turns to something close to night. A total solar eclipse happens only because of a strange coincidence of scale. The sun is about 400 times wider than the moon, but it also happens to sit about 400 times farther away, meaning both objects appear almost exactly the same size in our sky. During totality, the moon covers the sun's bright face completely, revealing the sun's faint, wispy outer atmosphere called the corona, glowing pale and silvery around a perfectly dark disk. Birds sometimes grow quiet, temperatures drop noticeably, and a strange, eerie twilight settles over the landscape, even at midday, before the sun's light gently returns just a few minutes later. It's one of the only times most people ever get to look directly at the sun's outer edges, offering a brief glimpse of a delicate structure that's normally lost entirely in the sun's overwhelming glare. It's a gentle, temporary alignment, this quiet cosmic coincidence of one object hiding another perfectly, for just long enough to remind us how carefully balanced these distances happen to be. There is something else worth resting on for a moment. Our entire galaxy, along with its neighbors, is being pulled gently toward something enormous and largely hidden, tucked behind the crowded, dust-filled center of our own galaxy. Astronomers noticed decades ago that our galaxy, and a great many others nearby, all seem to be drifting steadily in the same general direction, pulled by the combined gravity of an unusually massive concentration of galaxies. Because this region sits almost directly behind the Milky Way's dense central bulge, it's difficult to observe directly, and so it earned the quiet, slightly mysterious name of the Great Attractor. We now understand it as an especially crowded, gravitationally rich region where many galaxy clusters gather, part of a still larger structure researchers are slowly mapping in more detail. Even so, calling it the Great Attractor still captures something true and a little wondrous, an enormous, patient pull, tugging gently at galaxies from behind a curtain of stardust. Even our galaxy, vast as it feels from here, is quietly drifting, pulled along by something larger still, the way you might be gently pulled towards sleep by something you can't quite name. There is something else worth resting on for a moment. Long before anyone could measure a galaxy's distance directly, astronomers found a patient, careful way to build a ladder of distances, one careful rung at a time. The nearest stars can be measured using parallax, a gentle trick where a star's position appears to shift very slightly against more distant background stars as Earth orbits from one side of the sun to the other. That tiny shift, smaller than the width of a hair held at arm's length, is enough to calculate distance using simple geometry. The same principle your own two eyes use to judge how far away something is. For stars too far away for this trick to work, astronomers use other patient methods. Certain kinds of pulsing stars whose brightness reveals their true distance, or the reliable, predictable glow of a certain kind of exploding star. Each method only works for a certain range of distance, so scientists link them together carefully, rung by rung, building what's sometimes called the cosmic distance ladder. It's a very patient kind of trust, each rung resting gently on the one before it, allowing us to measure distances so vast that no single method could have reached them alone. There is something else worth resting on for a moment. Comets and certain cold, dark clouds between the stars both carry something quietly familiar tucked inside them. Water, frozen since long before the sun existed. Deep inside interstellar clouds, water molecules form on the surface of tiny dust grains, coated in thin layers of ice, drifting for millions of years in extreme cold. Some of that ancient ice became part of the material that formed comets, which still carry frozen water, along with other simple compounds, preserved gently since the solar system's earliest days. Some scientists think comets may have delivered at least some of Earth's water, colliding gently with the young planet over its early history, adding their ancient ice to the oceans that would eventually cover most of the globe. It's not the whole story of where Earth's water came from, but it's a lovely possibility to sit with. Some of the water resting quietly in a glass beside your bed tonight may carry, folded somewhere within it, a memory of ice that formed in the freezing dark between the stars, long before Earth existed at all. There is something else worth resting on for a moment. The sun doesn't just glow steadily. Every so often, it releases sudden, powerful bursts of energy, flinging enormous clouds of charged particles out into space. These eruptions, called solar flares and coronal mass ejections, can release more energy in a few minutes than humanity uses in a very long time, sending waves of radiation and charged particles outward through the solar system. When a large eruption happens to be aimed toward Earth, it can intensify the aurora, sometimes making it visible far closer to the equator than usual, glowing gently, even in places that rarely see it. These solar storms can also interfere with satellites, radio signals, and power grids. A gentle, but sometimes disruptive reminder that our quiet, steady sun is still. Underneath its calm daily glow, a genuinely turbulent and powerful star. It's worth resting on gently, that same sun, rising softly every morning outside your window, occasionally throws enormous storms of charged particles across millions of miles, mostly missing us entirely, mostly unnoticed. Except for the rare night, the sky quietly glows green. There is one more thing worth noticing before we drift onward. Not every message from space arrives as visible light. Some arrives as invisible radio waves, patiently gathered by enormous dish-shaped telescopes listening to the sky. Radio astronomy has revealed things ordinary telescopes never could. The faint, ancient microwave glow left over from the early universe, the rapid, ticking pulses of distant pulsars, and even naturally occurring cosmic masers, clouds of gas that amplify certain radio frequencies the same way a laser amplifies light, glowing brightly at wavelengths far beyond what our eyes can see. Enormous radio dishes, sometimes built into natural valleys or scattered in quiet, remote deserts far from human interference, spend their nights patiently listening, gathering whispers of radio light that have often been traveling for millions of years before finally arriving. There's a quiet stillness to it, worth borrowing for yourself tonight. Enormous instruments, built simply to listen patiently to whatever the universe happens to be quietly saying. There is something else worth resting on for a moment. Long before spacecraft had powerful enough engines to reach the outer planets efficiently, engineers found a gentler way to borrow a little extra speed, stealing it carefully from a passing planet's own motion. A gravitational slingshot works by letting a spacecraft swing closely past a planet already in motion around the sun, borrowing a small, careful portion of that planet's own momentum to gain speed. The same way a small stone might pick up a bit of extra motion brushing past something already moving. Several spacecraft exploring the outer solar system used a careful sequence of these gentle assists, planet by planet, to reach speeds their own engines alone could never have provided. It's a patient, almost graceful kind of physics, not forcing a path through space with brute strength, but borrowing gently, one careful pass at a time, from bodies that were already patiently moving. There is one more thing worth noticing before we drift onward. An astronomer once suggested a gentle way to make the universe's enormous age feel a little more human. Imagine the entire history of the universe compressed into a single calendar year. On this imagined calendar, the universe begins at the very first moment of January the 1st, and the present moment falls at the very last second of December the 31st. On this scale, the Milky Way doesn't form until springtime. The sun and earth don't appear until late August. The first simple life doesn't emerge until September. And everything most people consider human history, every war, every poem, every quiet night like this one, fits into just the last few seconds before midnight on the final day. It's a gentle, humbling way to hold the scale of things, not to feel small in a discouraging way, but small in a restful one. A reminder that you don't need to carry the weight of the whole universe's history. Only this one quiet moment near the very end of a very long year. At the very center of our galaxy, and most others, sits something almost unbelievably massive. A black hole millions, or even billions of times heavier than the sun. Our own galaxy center hides one of these giants, quietly anchoring the Milky Way's slow rotation, orbited by a small cluster of stars, moving fast enough that astronomers have been able to track their paths over just a few decades, tracing tidy, looping orbits around something completely invisible. Watching those stars swing around empty-looking space at such enormous speeds was one of the clearest pieces of evidence that something both massive and dark sits quietly at the center. Despite its enormous mass, this central giant isn't actively devouring anything dramatic most of the time. It sits largely quiet, its immediate surroundings calm, occasionally lighting up faintly when a stray cloud of gas drifts too close. It's an odd, quiet kind of anchor, sitting at the very heart of the galaxy you live in, holding everything in its slow, patient orbit, without ever once announcing itself directly. There is something else worth resting on for a moment. Just as planets orbit stars, some planets beyond our solar system may have their own moons, quietly circling worlds we've only recently learned to detect. Detecting an exomoon is far harder than detecting the planet it orbits, since its gravitational tug on its host planet is faint, and its light is fainter still. But a handful of candidate exomoons have already been proposed, some large enough to be roughly the size of Neptune. If moons are as common around other planets as they are around our own solar system's planets, there could be an enormous number of them scattered throughout the galaxy, entirely uncounted. Some scientists wonder whether certain large exomoons, warmed gently by their host planet, the way Europa and Enceladus are warmed by Jupiter and Saturn, might even hold their own quiet oceans, tucked beneath icy shells, circling worlds far larger than Earth. It's a gentle thought to rest on, that somewhere out there, a moon much like our own may be quietly circling a distant planet tonight, catching a soft, borrowed light from a star we haven't even named yet. There's something else worth resting on for a moment. For as long as telescopes have been pointed at Jupiter, a single enormous storm has been swirling across its surface, wide enough to swallow the entire Earth inside it. This storm, called the Great Red Spot, has been observed for at least a few hundred years, and may have existed even longer, churning steadily in Jupiter's thick atmosphere, its winds reaching speeds far fiercer than any storm on Earth. It has slowly shrunk over the past century, though it remains large enough to be seen clearly through even a modest telescope from Earth. Unlike storms here, which are fed and eventually worn down by contact with solid ground and ocean, Jupiter's storm swirls endlessly above an atmosphere with no solid surface to disrupt it, allowed to simply continue, largely undisturbed, for centuries at a stretch. It's strange to imagine a single storm, older than any living person's family history, quietly turning again and again in the thick, colorful clouds of a planet with no ground at all to slow it down. There is something else worth resting on for a moment. Some scientists have gently wondered whether life on Earth might not have started here at all, but arrived instead, carried quietly from somewhere else. This idea, called panspermia, suggests that simple microbial life, or at least the basic chemical building blocks for life, could survive a long journey through space, tucked inside meteorites or comets, eventually seeding a young planet like early Earth. It remains a hypothesis rather than an established fact, but experiments have shown that certain hardy microorganisms and organic molecules really can survive extreme cold, vacuum, and radiation for surprisingly long stretches. Whether or not life's first seeds truly arrived from elsewhere, the deeper idea sits gently alongside everything else we've wandered through tonight. That very little in this universe is ever entirely isolated, and even the beginning of life may have been, in some quiet way, a shared inheritance. There is one more thing worth noticing before we drift onward. Earth carries an invisible, quietly protective shield, generated deep within its molten core, that most people never think about at all. Currents of molten iron churning far beneath our feet generate a magnetic field that extends far out into space, deflecting most of the sun's steady stream of charged particles safely around the planet, rather than letting them strike the surface or atmosphere directly. Without this quiet shield, the solar wind would likely have stripped away much of Earth's atmosphere over billions of years, the way it seems to have done to Mars. The same magnetic field that quietly protects us also gently funnels a few particles down toward the poles, where they collide with the upper atmosphere and glow softly as the aurora, turning an invisible act of protection into one of the most beautiful sights in the sky. It's a strange comfort, worth resting on gently, an entire planet, quietly wrapped in an invisible field it can't feel or see, shielding it faithfully every day, without ever asking for anything in return. There is something else worth resting on for a moment. Not all star clusters are old and densely packed. Some are young, loose, and drifting apart even as we watch them. Unlike the ancient, tightly bound globular clusters near the edges of the galaxy. Open clusters form within the galaxy's spiral arms, made of stars born together from the same cloud of gas, only loosely held by gravity. Over tens or hundreds of millions of years, these young siblings slowly drift apart, pulled gently in different directions by the passing gravity of other stars and clouds, until they eventually scatter fully into the wider galaxy. Some of the brightest, most recognizable little clusters visible to the naked eye are exactly this kind: young, hot, blue-white stars, still loosely gathered, not yet fully scattered into their separate, solitary paths. Somewhere above you tonight, a small group of stars, born together only a few tens of millions of years ago, may still be loosely traveling together, not yet ready to drift their separate ways. There is something else worth resting on for a moment. Around many young stars, especially newly formed ones, astronomers have spotted faint, flattened disks of gas and dust, quietly swirling in the same shape our own solar system once had. These are called protoplanetary or debris disks, and within some of them, small clumps and gaps have already begun to appear, gentle evidence that planets may be quietly forming right now, in real time, around stars far younger than our own sun. Watching one of these disks is a little like being handed an old photograph of our own solar system's earliest days, except this photograph is happening live, somewhere out there, this very year. It's a quiet, ongoing kind of creation, worth resting on gently new worlds, somewhere among the stars, are being patiently assembled tonight, out of dust, exactly the way Earth once was. There is one more thing worth noticing before we drift onward. Careful, patient measurements suggest that the overall shape of the universe, on the largest scales, appears to be flat, rather than curved. If you imagine drawing an enormous triangle across the universe, using the paths of light as its straight edges, its angles should add up to exactly what you'd expect from ordinary flat geometry, rather than more or less, the way they would on a curved surface, like the inside or outside of a sphere. So far, every careful measurement fits this flat picture closely, suggesting space itself stretches out evenly, without curving back on itself the way a globe does. It's a strange comfort to hold gently, that, on the largest possible scale, the universe seems to behave simply, evenly, without any hidden curve waiting to surprise us. There is something else worth resting on for a moment. Trillions of ghostly, nearly massless particles called neutrinos are passing through your body right now, and will keep doing so for as long as you sit quietly tonight. These particles are produced constantly by the sun's core, by exploding stars, and by the universe's earliest moments, streaming outward in every direction at nearly the speed of light. They interact with ordinary matter so rarely that they pass straight through entire planets, almost as if nothing were there at all, which is why detecting them requires enormous, carefully shielded tanks buried deep underground, patiently waiting for the rare, faint signal of one finally colliding with something. It's a strange, gentle thing to consider, an invisible rain of particles from the sun and the early universe, falling through you constantly, quietly, without you ever once feeling a single drop. The moon doesn't create its own light, and it doesn't actually change shape. What changes is simply how much of its sunlit half we happen to see from Earth. As the moon orbits Earth, the angle between the sun, the moon, and us shifts gradually, slowly revealing more or less of the moon's bright, sunlit side. At new moon, the sunlit half faces entirely away from us, leaving the visible side dark. 2 weeks later, at full moon, the sunlit half faces almost entirely toward us, glowing whole and bright against the night. In between, we see the moon as a slowly growing or shrinking sliver, a gentle, unhurried progression that repeats itself roughly every 29.5 days, a rhythm so steady and predictable that early calendars were often built directly around it. It's a small, quiet reassurance, worth noticing tonight, a shape in the sky that never truly disappears, only turns gently away for a while, patiently returning, full and whole, every single month. There's something else worth resting on for a moment. When a star somewhat like the sun, though a little larger, finally reaches the end of its life, it doesn't collapse violently. It exhales gently into one of the most beautiful sights in the sky. As such a star runs low on fuel, its outer layers drift outward in a slow, gentle wind, forming an expanding, glowing shell of gas around the small, hot core left behind. Lit from within by that leftover core, these shells glow in soft, delicate colors, rings, and loops, some resembling butterflies, others rings, others soft hourglass shapes, entirely by the quiet physics of gas expanding outward in every direction. These glowing shells are called planetary nebulae, a slightly misleading name from early astronomers who thought their round shapes resembled planets through smaller, older telescopes. They typically last only a few tens of thousands of years, cosmically speaking, a brief, glowing exhale before fading quietly into the dark. It's a gentle image to hold on to, a star's ending, rendered not as violence, but as something closer to a soft, colorful, unhurried breath, releasing outward into the dark. There is something else worth resting on for a moment. Unlike every other planet in the solar system, Uranus spins almost completely on its side, as though it had simply tipped over long ago and never quite gotten back up. While most planets, including Earth, spin somewhat upright as they orbit the sun, Uranus's axis is tilted more than 90 degrees, meaning it essentially rolls along its orbit rather than spinning upright. Scientists suspect an ancient, massive collision knocked it onto its side sometime in its early history, and it has simply continued rolling that way ever since. This extreme tilt gives Uranus some of the strangest seasons in the solar system. Each pole spends a quarter of the planet's very long year, over 20 Earth years at a stretch, either bathed in continuous sunlight or plunged into continuous darkness. It's an odd, gentle thing to imagine, an entire planet quietly rolling through space on its side, patiently keeping its own strange, slow rhythm of decades-long days and decades-long nights. There is one more thing worth noticing before we drift onward. Neptune, the solar system's farthest known planet, is home to the fastest winds ever measured on any planet, tearing through its cold, blue atmosphere at speeds faster than the speed of sound on Earth. Despite receiving only a faint whisper of the sun's warmth this far out, Neptune's atmosphere churns with enormous storms and streaking, high-speed winds, driven by some internal source of heat that isn't yet fully understood, since sunlight alone can't easily explain such fierce activity so far from the sun. Pale blue clouds of frozen methane drift across its surface, sometimes gathered into dark, swirling storm systems as large as Earth itself. It's a strange, quiet contradiction, worth resting on gently. One of the coldest, dimmest places in the solar system, also hosting some of the fastest, most violent winds of any planet we found. There is something else worth resting on for a moment. The sun's surface isn't perfectly smooth or unchanging. It's dotted at times with darker, slightly cooler patches called sunspots, which grow and fade over a slow, steady 11-year cycle. These sunspots form where the sun's magnetic field grows unusually tangled and concentrated, temporarily suppressing the flow of heat from below, which makes them appear slightly darker and cooler than the surrounding surface, though still far hotter than anything on Earth. Over roughly 11 years, the number of sunspots rises to a peak, then fades to a quiet minimum, before slowly rising again, a patient rhythm the sun has kept for as long as we've been carefully watching it. During busier periods of this cycle, the sun tends to release more flares and eruptions, gently intensifying the aurora here on Earth, a quiet, distant echo of the sun's own slow, internal heartbeat. It's worth resting on gently tonight. Even the sun, steady and reliable as it feels, keeps its own slow, 11-year rhythm of quiet and activity, breathing in and out over more than a decade at a time. There is one more thing worth noticing before we let this part rest. Earth isn't the only planet with shimmering polar lights. Jupiter and Saturn have auroras too, far larger and more powerful than anything visible from the ground here at home. Both giant planets have magnetic fields far stronger than Earth's, capturing and funneling charged particles toward their poles, where they collide with the upper atmosphere and glow, much the way Earth's aurora does, though usually in ultraviolet light, invisible to our eyes without special instruments. Jupiter's auroras are powered partly by particles from the sun and partly by material flung out from volcanic eruptions on one of its closest moons, adding an extra, unusual source of glowing particles. It's a quiet reminder that this soft, glowing phenomenon, the one you might associate with a single clear night at home, is happening in its own enormous, patient way on other planets too, glowing gently around worlds far larger than our own. Space itself is almost perfectly silent, not because there's nothing happening out there, but because sound, unlike light, needs something to travel through. Sound moves as a vibration, passed from one particle to the next, through air, through water, through solid ground. But the space between planets and stars is so thin, so nearly empty of any particles at all, that there's almost nothing there for sound to push against, meaning even the most violent event imaginable, two stars colliding, an entire star exploding, would happen in complete, total silence, at least from any distance at all. Some of the dramatic sounds of space, occasionally shared online, are actually something else entirely. Invisible radio waves or vibrations in thin cosmic gas, patiently converted into audible sound here on Earth, translated for our ears the way a photograph translates light into something a printer can reproduce on paper. It's a strange, gentle thing to picture. Some of the most powerful events in the entire universe unfolding in perfect, complete silence, simply because there was nothing nearby soft enough or close enough to carry the sound of them. There is one more thing worth resting on before we let this part go. Everything in the universe seems to drift, slowly and patiently, from order toward disorder, a quiet tendency scientists call entropy, and it may be the closest thing physics has to an arrow pointing toward the future. Ice cubes melt into water and never spontaneously reform on their own. A cup of hot tea cools to match the room around it, never the other way around. Stars burn their ordered fuel into more disordered light and heat, radiating outward, never gathering it back in. On the largest scales, the whole universe seems to be doing something similar, very slowly, very patiently, over spans of time too large to picture clearly. This isn't something to feel unsettled by. It's closer to the quiet logic behind rest itself, energy spreading out, settling, easing from something tense, and concentrated into something calmer and more spread out, the same shape, in its own way, as a long, unhurried exhale. You don't need to hold onto this idea tightly. It's simply the universe's own, very slow way of doing exactly what you're doing right now, gently, patiently, letting go. Some stars almost formed, but never quite made it all the way. Brown dwarfs sit in a quiet, unfinished space between the largest planets and the smallest true stars. They gather enough mass to glow faintly with their own dim heat, but never quite enough to sustain the kind of steady hydrogen fusion that powers a true star like the sun. So they simply glow faintly in deep infrared light invisible to our eyes, cooling slowly over billions of years, drifting through the galaxy as dim, half-finished embers. Some scientists call them failed stars, though that always feels a little unfair. They're not failures. They're simply something quieter, something in between, existing steadily, needing nothing more from the universe than to keep cooling slowly in their own time. There's something else worth resting on gently for a moment. Many stars in the sky aren't alone at all. More than half of all sun-like stars share their light with at least one companion. Two stars, bound together by gravity, slowly circling a shared center, sometimes for billions of years. From a planet orbiting such a system, the sky might show two suns rising, casting two sets of shadows, blending into a single, doubled twilight each evening. Our own sun happens to be a solitary star, quietly on its own. But most stars, it turns out, share their long lives with a companion, drifting through the dark together, never quite alone. There is one more thing worth noticing softly before we drift onward. Around the edges of our galaxy, and around many others, hang faint, round clusters containing hundreds of thousands of stars, packed closely together, some of the oldest stars in the entire universe. These are called globular clusters. Many of their stars formed over 10 billion years ago, nearly as old as the universe itself, and have simply continued orbiting together quietly ever since. A planet inside one of these dense star clusters might never experience true darkness. The sky there would glow always with thousands of nearby stars, a permanent, gentle twilight, never quite fading into black. Some of the oldest light still shining tonight comes from these ancient, crowded little cities of stars, patient, glowing softly at the very edge of our galaxy's reach. There is something else worth resting on gently for a moment. Some of the brightest single objects in the universe are not stars at all. They're called quasars, the blazing, glowing centers of distant galaxies, powered by enormous black holes pulling in gas, and dust so quickly that the material glows brighter than an entire galaxy of ordinary stars combined. Quasars sit so far away that their light has often been traveling for billions of years before it ever reaches us. Meaning, when we study one tonight, we're really watching the ancient, early universe, quiet history, still arriving. Somewhere out there, unimaginably far away, an enormous black hole has been glowing faithfully since long before Earth even existed. There's something else worth resting on gently for a moment. Sometimes light itself gets gently bent, not by glass or water, but by gravity. When light from a very distant galaxy happens to pass near something massive, another galaxy, or a cluster of galaxies, its path curves slightly, the way light bends passing through a lens. This is called gravitational lensing. It can stretch a distant galaxy's light into a faint arc, or even split a single distant light source into several duplicate images, scattered gently around the object bending it. It means gravity itself can act like a lens, letting us see galaxies so distant, so faint, that without this gentle bending, their light would simply be too faint to notice at all. There is one more thing worth noticing softly before we drift onward. Space itself can ripple, very faintly, when massive objects move. When two black holes spiral into each other far across the universe, they send tiny ripples through the fabric of space itself. Gravitational waves, stretching and squeezing space by an amount smaller than the width of a single proton. These ripples travel outward at the speed of light in every direction for millions or billions of years, until very occasionally they pass gently through Earth itself, detected by instruments sensitive enough to notice a stretch smaller than anything we can otherwise imagine. Tonight, faint ripples from ancient, distant collisions may be quietly passing through this very room, too small to feel, but real all the same. There is something else worth resting on gently for a moment. Right now, tiny particles from deep space are passing quietly through you. They're called cosmic rays, though rays isn't quite right. They're mostly fast-moving particles, flung outward from distant supernovae and other violent events, long ago and far away. Most are stopped safely by Earth's atmosphere before they reach the ground, but a few, faint and harmless, pass through everything, including your body, many times every day. Some scientists think these same particles, over billions of years, gently nudged the process of evolution itself. Small, quiet contributions to the long story of life. There's something else worth resting on gently for a moment. In 1990, a spacecraft leaving our solar system turned its camera around and took one last photograph of Earth. From nearly 4 billion miles away, Earth appeared as a single, pale, bluish speck, smaller than a pixel, suspended in a faint beam of scattered sunlight. Everyone who has ever lived, every home, every love, every quiet night like this one, happened on that one small, pale dot. It's a gentle thing to hold on to. From far enough away, everything is small and quiet and easily missed, and still, somehow, entirely enough. There is one more thing worth noticing softly before we drift onward. The universe is so vast and so old that it's natural to wonder, quietly, whether anyone else is out there. With so many stars, so many planets, some in gentle habitable zones, it seems strange that we've never heard from anyone else. Scientists call this quiet puzzle the Fermi paradox. Not a frightening mystery, just an open question resting patiently unanswered. Maybe life is rare. Maybe it's common but far away. Maybe it's simply quiet the way you are right now. Either way, the silence isn't empty. It's just very, very large, and you're allowed to rest inside it. There is something else worth resting on gently for a moment. Before the very first stars, there was a long stretch of darkness. For a few 100 million years after the universe began, there was no starlight at all, just cooling gas drifting quietly through the dark. Astronomers call this the cosmic dark ages. Then, slowly, gravity gathered the gas, and the very first stars flickered on, one by one, lighting the universe for the first time. This gentle beginning is sometimes called cosmic dawn. Even the universe itself needed time, patience, and darkness before its first quiet light. There is something else worth resting on gently for a moment. The universe is still expanding tonight, and as far as we can tell, it always will. Billions of years from now, the stars will burn out one by one, slowly, gently, with no rush at all. Galaxies will drift farther apart. The sky will grow quieter and darker over an unimaginably long stretch of time. This isn't a sad ending. It's simply a very long, very slow exhale, the same shape as sleep, the same shape as rest. Whatever happens, billions and billions of years from now, it is not happening tonight. Tonight, there is only quiet and stillness, and you. There is one last thing worth noticing softly before we let it all go. Every atom in your body came from somewhere unimaginably old and unimaginably far. Hydrogen from the universe's first quiet moments. Carbon and oxygen from stars that lived and died before the sun was born. Iron, old starlight, stardust, resting tonight in the shape of you. You are not separate from any of this. You are simply where the universe, very quietly, decided to pause for a while. There is one more thing worth resting on, gently, before we let it all go. Some of the very rocks and metals that first taught scientists what other worlds are made of never had to travel anywhere at all to be studied. They simply fell. Meteorites, fragments of asteroids, and occasionally even small pieces of the moon or Mars. Sometimes survive the fiery trip through Earth's atmosphere and land gently, or not so gently, on the ground below. Some of these fallen fragments are older than the Earth itself, having formed in the earliest days of the solar system and drifted, largely unchanged, for over 4.5 billion years before finally landing somewhere on this planet. A few rare meteorites have even been traced back, chemically, to Mars, thrown loose by an ancient impact there, drifting through space for millions of years before finally arriving here, quietly, as a small, dark stone lying in a field. It's a strange, gentle kind of mail delivery, patient fragments of other worlds, sent with no address and no sender. occasionally arriving anyway, resting quietly in the grass until someone happens to notice they don't quite belong. There is one last thing worth noticing softly before we let this final part rest. For nearly all of human history, everyone who ever lived only ever knew a single sky, watched from a single, quiet vantage point on the ground. Only within the last handful of decades has anyone left Earth's surface far enough to look back and see the whole planet at once, small, blue, and whole, hanging quietly against the dark. Every single person who has ever felt afraid, or tired, or hopeful, or in love, lived their entire life on that one small, softly lit world, without ever once needing to leave it to matter. You too are living your whole life there, tonight, in one small, quiet corner of it, wrapped in a blanket, listening to a voice, doing absolutely nothing more urgent than letting your body rest. That has always been enough. It still is. There is one more quiet thing worth resting on before we finally let it all go. Some of the very first careful measurements of the universe's age came from patiently studying the faintest, oldest stars still burning quietly in our own galaxy. Certain ancient stars, formed not long after the galaxy itself, burn so slowly and so steadily that they've simply continued glowing, largely unchanged, for well over 10 billion years, acting almost like slow, patient clocks. By carefully measuring how such stars age, how their light gradually shifts as they use up their fuel over unimaginably long stretches of time, astronomers found a lower limit for how old the universe must be, since nothing inside it could possibly be older than the universe that contains it. These same slow-burning stars are often found clustered in the old, dense star cities we wandered through earlier tonight, quietly outlasting entire eras of galactic history, watching in their own patient way as newer, younger stars are born and burn out around them. It's a gentle, steadying thought to end on that scattered quietly through our own galaxy right now. Some of the very oldest light in the universe is still faithfully glowing, having already outlasted almost everything else, and in no hurry at all to stop. You don't need to hold onto any of this now. The stars, the black holes, the ancient light, the quiet dust that became you. It can all soften now into a gentle blur, the way a long day softens into evening. There's nothing to remember, nothing to carry forward. You've already let it wash over you gently, and that was always enough. Let your body settle a little further now, heavier, warmer, into wherever it's resting. Let your breathing slow just a little more, in and a long, easy out. Let your shoulders soften completely now. Let your hands unclench gently wherever they're resting. Let your jaw rest, loose and quiet. No need to hold anything at all. Let your feet grow heavy. Let your legs grow heavy. Let that same heaviness spread slowly upward, the way warmth spreads through a room, filling every quiet corner of you, one soft, unhurried inch at a time. There's nothing left to do tonight. No thought to finish. No fact to hold on to. Just this soft, quiet stillness settling in around you like a blanket. Above you right now, whether you can see it or not, the sky is still turning slowly, the way it always has. The stars are still burning patiently, the way they always do. Somewhere, a new star is quietly being born. Somewhere else, an old one is gently letting go. None of it needs you to watch it happen. It will keep turning softly, steadily, all night long and long after tonight too, just as it always has, just as it always will. You can let go now, the same way it does. Your body already knows how to rest. Sleep well and good night.